Welcome to Lesson 7, Logical Operators. In this video, we're going to use the words and or to create more complex decisions by having the ability to combine individual conditions together. What you're going to find is that the words and or have the same meaning as they do in our natural language, and we're just simply going to extend that to programming. So let's get to it. So this being an overview lesson, we're going to stick strictly to just the logic of how the and the or operators. The next video will show an actual programming example using the Circuit Playground Express. So let's say we had a variable x and we set it equal to 7. We could write a decision that checks to see if x is, let's say, less than 10. Okay. And then we could do some process that prints out. Okay. But what if we wanted to extend that understanding not just to one variable, but perhaps two variables? So let's say we had another variable y, and it was equal to 5. So we only wanted to print the words okay if the value of x was less than 10 and the value of y was less than 10. Now, the way I said it is actually the same way you write it. So I'm going to erase this for a second. And I'm going to write the and operator. All right, so this is the and operator. And let's just use our natural understanding of logic to see if this expression evaluates to true. So is x less than 10? Well, yeah, 7 is less than 10. And is y equal to 5? Okay, so y is equal to 5. That is correct. I realized that in my original example, I was going to check to see that this is less than 10. So let's just do the same thing here. Let's just to make life easy. But it's really about, asking ourselves if that individual condition is true. So it happens to be both conditions are true, which means we will print this out. Now let's switch around some of our values. Let's make this, let's say, 11. Okay, so now we ask ourselves, is x less than 10? No, it's 11. So at this point, you kind of understand, well, we needed both things to happen. It's like this and that. So it's not enough just to have one side of it, but let's go ahead and check out the other side anyway. So y might be less than 5, but guess what? X is not less than 10, so we won't print this out. Let's switch this around now to this being back to 7, and let's maybe make this 15. All right, so let's go back to our expression. So we ask ourselves, is x less than 10? Well, yeah, it's 7. And is y less than 10? No, y is 15. So this side kind of fails. It's not true, so we don't print it out. And I think at this point, you could also kind of figure out, let's do this scenario where both values are over 10. So again, let's just go back to the decision. Let's say, if x is less than 10, well, x is not less than 10, it's 17. So we fail this side. But let's go ahead and just for the sake of review, the computer actually doesn't do this. This is a bigger concept called short-circuiting, which I'll leave for a later video. So x is not less than 10 and y is not less than 10, so we don't print this out. So that's our natural understanding. So notice I really didn't discuss the actual mechanics of the and operator. We kind of just intuitively knew when it should happen. Now I'm going to go to the more traditional logic type explanation of this, and hopefully it doesn't scare you, which is the idea of using P's and Q's. So I want you to think of these scenarios, the P as being the x less than 10, and then the Q being the y less than 10. Okay, so there was a scenario where we found that the x was less than 10 and the y was less than 10. There was another scenario we tested out where the x was less than 10 but the y wasn't, and also the reverse where the x wasn't less than 10 but the y was. And then our last scenario was the fact that neither value was less than 10. And what we found was that, let me just write this here, that when both values, both conditions were met, then it naturally kind of led us to understand that, okay, that we've met all the conditions, let's go ahead and print out that okay. But anytime any value, any condition was not met, then we weren't printing out the value. And that is how the AND operator works. That the only time an expression, a decision that involves the AND operator evaluates to true is if all the individual conditions are true. And again, just extending this to our natural language, you've heard people say, well, you need to do this and that. Again, it's not a choice. You got to do both things. And that's the same thing here. That in order for a condition that has the AND operator to do its job, all the individual conditions have to evaluate to true. Now, another logical operator, and we're going to take the same approach to this, is the OR operator. Because sometimes it's not about doing both things, but it's about doing at least one of those two things. So we're going to go back to our same setup of an x, let's say, of 5, and our y of 7. And let's write our if statement. So we'll say x less than 10 or. So this is the logical operator or. That's how you write the word or in programming. Now, if you're curious, how do you produce that symbol, the two vertical lines? That's above your enter key. So if you look at your enter key, you're going to see vertical lines. Sometimes they're labeled like this with two dash vertical lines. Don't worry, the dashes don't pop up. That was done more so it wouldn't be confused with like the letter I or some other character. But that symbol with the two vertical lines prints out one vertical line. Okay, so going back to our same scenario of, let's see if we can print out the word okay. So let's ask ourselves, is x less than 10? Well, it is. Or is y less than 10? Okay, so in this case, it happens to be that they're both less than 10. So we're going to print out the word okay. Let's flip this around. Let's make this 17. So we go back to our scenario here. So is x less than 10? It is. Or is y less than 10? Well, y is not less than 10, but guess what? The x is. Remember, that's how our or understanding for our natural language works. It's either this or that or any of them. As long as something is being satisfied. So it happens to be that the x is less than 10, so we're going to print this out. Let's flip this around. So is x less than 10? It's not. It's 15. Or is y less than 10? Well, it happens to be y is less than 10. So at this point, we're going to print out the words okay as well. Now let's go, I believe this is our last combination. So now let's ask ourselves, is x less than 10? It's not. Or is y less than 10? It's not either. So neither condition is being met, which means we don't print out the word okay. So hopefully you saw that. In this case, neither condition was met. So we can't print it out. Up until now, we were pretty much printing out everything. Whether this condition evaluates to true, and this condition evaluates to true, or this condition evaluates to true, and not this one, and vice versa. Again, now let's go to our traditional review of logic using what's called the logic table. That's what it was that I created in the AND example. So we're going to go back to our P's and Q's. And if you recall, the P can be thought of as the x less than 10, and the Q could be thought of as our y less than 10. So we had a scenario where both conditions were met. We had a scenario where one of the conditions were met. And then we had a scenario where none of the conditions were met. Again, referring back to those two, x less than 10 and y less than 10. And now we wanted to evaluate whether, any of the conditions was being met. That's how the OR works. So it's either this or that. Right? One of the two things has to be met in order for us to evaluate. So it happens to be if we've met both conditions, then yeah, we're going to do the thing. If we met the first condition but not the next one, that's okay, because it's an OR. It's one of these. Same thing with this one. The first condition wasn't met, but the second one was. Again, that's okay, as long as one of the conditions was met. And then this last one is, well, none of the conditions were met, so this is the one scenario where it results in false. So I want you to, listen to some of the words that I was saying where, these, at least one condition is met. Okay, that's one way of thinking of it. That the OR statement, as long as one of the conditions is being met, you're good to go. The other way you could think about this is kind of like the opposite, where the only time the OR statement doesn't evaluate to true is when none of the conditions evaluates to true. Again, and these are easy ways for you to remember how these logical operators work. All right, so let's go back to our presentation and review what we have. All right, so we discussed the logical operators of and or, which are words that are used in our natural language. So hopefully you're able to kind of pull from that when writing your decisions in programming. But just as a quick review, the and operator only evaluates to true when all the individual conditions evaluate to true. And then the or operator evaluates to true when at least one of the conditions evaluates to true. All right, so hopefully you feel a little more empowered, and hopefully you also see how programming is just an extension of our natural language. And the more you do this, the more you'll realize that. All right, so look forward to seeing what you could create. Enjoy.